In the summer of 2023, competition in the beverage market has reached an unprecedented level. In this challenging environment, XYZ Beverage Bottling is an industry leader with a strong commitment to product quality and customer satisfaction. A core automatic filling machine in the plant undertakes the task of ensuring that each bottle of beverage is accurately filled with 500 ml, which is the key to maintaining product consistency and brand image. However, recent feedback from the market and internally has alerted the quality control team. Some customers have complained about the insufficient filling of beverages, while internal quality checks have also revealed fluctuations in filling volumes. These problems not only affect the reputation of the product, but can also lead to higher costs and lower profits. To address this challenge, Joan Doe, head of quality control, decided to take decisive action to verify the filling accuracy of the machines through scientific statistical methods and in-depth analysis, and to fully assess its impact on the business. This is the outline we are going to talk about next. The objective of this analysis is not only to determine whether the filling volume of the machine is accurate, but also to further quantify the extent of the deviation and assess its impact on profits, costs, customer satisfaction, and market competitiveness. At the same time, it will also explore other factors that may affect the filling volume, such as the operating state of the machine, the skill level of the operator, the quality of the raw materials, and make comprehensive suggestions for improvement. Joan carefully designed the data collection scheme to ensure the randomness and the representativeness of the sample. He chose a typical production day, took a random sample of 50 drinks, and made volume measurements using high-precision measuring cups. In addition to collecting data on the volume of filling, he also recorded the operating time of each machine, the name of the operator, the batch of raw materials, and other information for more comprehensive analysis. In the data analysis stage, Joan conducted detailed descriptive statistical analysis, including the calculation of mean, median, standard difference, and other indicators. He found that the average filling volume of the samples was 499.8 ml, slightly below the set value of 500 ml. The median was 500 ml, indicating that the data distribution was symmetrical. The standard deviation is 2.8 ml, reflecting the fluctuations of filling volume. To get a deeper understanding of the distribution of filling volumes, Joan also drew histograms and box plots. The histogram shows the frequency distribution of filling volumes, while the box plot reveals the degree of dispersion and outliers of the data. Using these charts, Joan was able to more intuitively understand the fluctuations in filling volumes and potential problems. In order to scientifically verify that the filling volume is accurate, Joan performs a rigorous hypothesis test. He assumed the null hypothesis. The average filling amount is equal to 500 ml. Alternative assumption: the average fill amount was not equal to 500 ml. The 95% confidence level was used and the calculation was performed by t-test. In calculating the t-value, Joan considers factors such as the sample size, the difference between the simple mean and the assumed mean, and the standard difference. He calculated a t-value of negative 0.41, indicating a small degree of difference between the simple mean and the assumed mean. Since the t-value falls within the critical value, (-2.01 to 2.01). The null hypothesis cannot be rejected. In order to further verify the reliability of the conclusion, Zhun also calculates the p-value. The p-value was 0.685, much higher than the significance level of 0.05, which further supports the conclusion that the null hypothesis cannot be rejected. However, Zhun did not stop here. He also considered other factors that might affect the conclusion, such as sample size, measurement error, and conducted corresponding sensitivity analysis. In order to quantify the impact of feeding volume deviations on profit, Zhun conducted a detailed profit modeling. He considered the cost structure of each bottle of drink, including the cost of raw materials, production costs, filling costs, and calculated the cost loss caused by each missing one meal. He found that each missing one meal resulted in a cost loss of $0.02, so the average loss per bottle due to insufficient filling was $0.004. Based on this finding, Zhun further estimated daily and annual losses. Assuming that 10,000 bottles of drinks are produced daily, the daily loss is $40. Assuming 300 days of production per year, the annual loss is as high as $12,000. This discovery aroused great attention from management, who realized that measures must be taken to reduce losses and improve profits. In addition to calculating direct losses, Zhun also performed a break-even analysis. He considered the trade-off between the cost of the machine adjustments and the potential loss, and calculated the break-even point. He found that making machine adjustments is economically feasible when the cost of machine adjustments is less than the potential loss. However, Zhun does not stop at the level of economic analysis. He also considers other factors such as customer satisfaction, brand image. He believes these factors are just as important, if not more so, than economic factors. Therefore, he recommends that management consider multiple factors when making decisions and develop a comprehensive improvement strategy. In his in-depth analysis of the reasons for the feeding volume deviation, Zhun found that there were several other factors that could affect the feeding volume besides the machine itself. For example, the skill level of the operator, the quality of the raw materials, the temperature of the production environment may have an impact on the feeding volume. To solve these problems, Zhun came up with a series of creative suggestions. First, he suggested strengthening the training and management of operators to improve their skill level and sense of responsibility. Second, he recommends working with suppliers to ensure the quality and stability of raw materials. In addition, he also recommended strict control of the production environment to maintain appropriate temperature and humidity conditions to reduce the impact on the feeding volume. In addition to these direct-to-field suggestions, Zhun also came up with some other innovative ideas. For example, he suggested introducing advanced sensors and monitor systems to monitor changes in feeding volumes in real time and adjust machine parameters in a timely manner. He also suggested using big data and artificial intelligence technology to conduct in-depth analysis of production data to find potential problems and improvement points. Based on the above statistical analysis, profit modeling, and analysis of other influencing factors, John drew the following conclusion. At 95% confidence level, it is not possible to confirm that there is a significant deviation in the filling volume of the machine. Although the average filling volume of the sample was slightly below the target value, the error was within the acceptable range. However, considering the potential impact of filling volume deviations on profits, customer satisfaction, and market competitiveness, measures must be taken to improve. Through the implementation of this series of measures, XYZ beverage filling plant will be able to better ensure product quality, reduce cost losses, improve customer satisfaction, and market competitiveness. At the same time, these measures will also provide a strong guarantee for the sustainable development and innovation capacity of entire enterprise.